This is section 3.3, part 3, where we're going to graph a system of 3 or more linear inequalities. So sometimes you might have to graph 3, maybe even 4. So if you remember, I told you that a system of inequalities is 2 or more equations, and up to this point we've only dealt with 2. Alright, so same thing with inequalities, 2 or more inequalities. Here we're dealing with 3, and sometimes you may see 4 when you do some problems. So it's just one extra step. It's the exact same process. Graph each inequality and then use a test point to figure out which direction you need to shade. But now you need to do it for 3 of them. So let's graph the first inequality. Alright, so we have a y-intercept here of 2. We'll plot a point at 2, and we have a slope of -1. So I'm going to go down 1, right 1, or I could have gone up 1, left 1. It's less than or equal to, so that tells me it's a solid line. So I'm going to draw a nice solid line here. Next, I'm going to graph this one, and look, only one variable. So what happens when we have one variable? Well, it means you're either going to have a horizontal or a vertical line. So let's see what we have here. X is greater than or equal to 1. We know we plot the point 1 on the axis of the variable shown. So we have a point right here on the x-axis, and when we have a point on the x-axis, we know we have a vertical line. Because of the equal sign here, it's going to be a solid line, straight up and down, passing right through the point x equals 1. And lastly, we have y is greater than -2. So I plot a point on the y-axis, because again, just one variable. And we know when we have a point simply on the y-axis, we're going to have a horizontal line. There's no equal to here, so this is going to be a dashed line passing through y equals -2. Alright, so we've got our 3 lines drawn. Now we need to test our shading. Okay, so 3 equations. What's nice, none of the 3 lines pass through 0, 0. So from my test point for each equation is going to be 0, 0. I'm only going to write that once. Alright, I can use the same test point for all 3 here. So I've got y is less than or equal to the opposite of x plus 2. Plug in my zeros. The opposite of 0 is 0. 0 plus 2 is 2. So I have 0 is less than or equal to 2, which is true. Alright, so that's this line right here. I want to shade towards my test point. Alright, so that's all of this area. Next, let's use x is greater than or equal to 1. I'm going to use my test point of 0, 0 still. Only I have an x value, so I'm only going to put in this 0. 0 is greater than or equal to 1. That's false. So I want to shade away from x is greater than or equal to 1. So we have x is greater than or equal to 1 here. We do not want to include our test point. So I'm shading away in this direction. So right now it looks like we have an overlap right in here. Alright, but we can't say what the solution is yet because we have to test our third equation, which is y is greater than -2. There's our first equation, there's our second, here's our third. So again, plug in our zeros. I only have y, so I have to only plug in the y value, which is 0 here. Is 0 greater than or equal to -2? Well, that's true. Alright, so I want to shade towards that 0, 0. So that's going to be this area here. Alright, and so I want to, my solution is going to be where all 3 of the shadings overlap. Alright, all 3 of them. So I've got shading going in this direction. I have shading going in this direction. And I have shading going up. Where do all 3 of them overlap? That happens right in this little triangle right here. Oftentimes when we have three equations, or inequalities, when shading, you do see an overlap here. It's not 100% of the time, but if you see a triangle formed, it's quite possible that the overlaps will be within that triangle, but not 100% of the time. So, there's your answer. It's right in here. Okay.